Okay, so good morning, everybody. I'm Glenn Ricaud, a software developer at Enonic, and today my goal is to give you a quick overview in 20 minutes of what is GraphQL, why you might want to use it, and how did we use it in our PWA. So GraphQL, first of all, is a query language, so you could see it a bit like SQL, but between your client and your server API. It's also a server-side runtime to execute these queries against your data. For the story, it was developed internally by Facebook in 2012, and they have open sourced their specifications and their implementation in 2015. But so if I had to sum up the idea, is that the client gets back from the server all it needs and nothing more. And to do that, it sends a request containing the definition of what it needs. But I'll give you an example, it will be more clear. Okay, yeah, at my office, we play football a lot, table football. So we started to develop an application to keep track of score and rankings, score prediction, etc. So in this case, we have this kind of case where we need to display, for example, a player and the teams is a member of. So if we did our application with a classic REST API, for example, we would have this kind of communication. First, the client would ask the server to get the player information, give me this player. And the server will return all the data about this player, and then it will send a request, get me the teams he's a member of, etc. But from this example, you can see multiple problems here. First of all, you have multiple requests, and when it's sequential like this, it takes too much time. What I would like to have is to send a unique request and get everything I need back. So I've seen solutions that have tried this. Either they try to include everything the client might need, then it's bloated and you waste resources. Or they try to do a custom result for each use case. But that suppose that you don't have an open API, first of all, and also in the end, it's not maintainable. You end up duplicating your code. It's a hell to maintain. Also, I don't need all of this data. I don't need to know nationality, handedness, etc. I don't need these fields here. And lastly, we did a PWS, so that's not a problem here, but because you can force the update of your application, you can force it to be up to date. But in a classic application, you will change your API. You will add new fields, you will remove fields, and you don't want newer version of your application to see these obsolete fields, and you don't want the old version to see these new fields. So you will end up versioning your API basically. And that's also a problem. But for me, all of these problems and others have the same root, that we try to define on the server what the client needs, while it should be the client that tells us what it needs. And that's, I think, the idea of GraphQL. So here is the equivalent of the example in GraphQL in our application. So in GraphQL, you have a unique endpoint, and you will send all of your requests to this unique endpoint. So the client sends a post request containing a GraphQL query. That's the GraphQL query. It looks like JSON. It's not exactly JSON. So here how it's read. So get me the player. All fields can take arguments. So get me the player named Glenn. And for this player, I only need its ID. And I also need the teams he's a member of. But for these teams, I only need the name. And so this request is executed on the server, and you get a JSON response that has the exact same structure. So that's what we wanted. One request, everything I need, and no additional data. But another good point here is that tomorrow a developer that works on the client might need to have access to the leagues of a player, for example. In that case, it doesn't need to communicate with the developer working on the backend. It doesn't need to update the API. It simply needs to update its query, send it to the server, and it will get an answer that is adapted to its need. And so, we don't change the API, and there's no impact on others. So that was quite nice when we developed our application. Okay, but now, if you want to implement it yourself, what should you do? It was actually quite simple. On the client, we send all the requests to the single endpoint, and we get a JSON back. On the server, you will first select a server-side framework. There's one for all languages, Java, JavaScript, Python, anything. And you will define the schema of your API. So in GraphQL, everything is a type. So for example, a player team, it's a type. So we'll define the type, the fields. Here you can see maybe ID teams, and the way to resolve these fields. And this, and this resolution is of course done only on demand. If I don't need the teams of my player, then it's not resolved, of course. So, but here is an example, for example, of the definition of a type. So, yes, some additional features that might be interesting. Mutations. I talked about queries. Mutation is the same, but it has an impact on the state of your server. So all of your create, update, delete, that's in GraphQL, that's a mutation. You will use variables, you can paginate. GraphQL defines a way to introspect your schema, so a lot of tools have popped up to that does validation of requests. They generate documentation for your API for free. Yeah, so a lot of good features. But what was missing when we developed our app? First of all, the binaries. There's no specification on how to serve binaries. So what we did is we generate a URL that points to a classic REST service. And subscription, that's not the case now, but when we started, there was no official definition. A subscription is how to be pushed an event that data has changed on the server. So there was no official specification at that time, but now it has changed, and implementation starts to support it. In the intro, I said that we mixed GraphQL and PWA. It doesn't have much impact. But one thing to note is that PWA relies a lot on caching, and GraphQL makes it a bit heavier or more complex to cache. Yes. So yeah, here in one slide, some caching strategies we adopted and choices we made. When our application is offline, we disable everything using mutation, so create, update, delete. But we could have used background synchronization. So it's creating a task that will be run when you get back the connection. On the installation of our application, we cache everything that is static, so we don't need to fetch it after. But we also pre-cache all the GraphQL data that is essential to work offline. So once it's installed, it should work offline. So I talked about binaries. I said that we generate URL. But for the dynamic one, like the profile of a user, it might change. So we generate it with a hash so that we can know if it's cached, then we know that it's the correct version. We don't need to fetch it anymore. And last point, GraphQL. You have to think about that your application might be offline or have a slow connection. So what you want to do is to serve directly the data from the cache to have an instant display, and at the same time fetch from your GraphQL service information more up to date, and then update the display when you retrieve this information. So yes, that's all. If you want to know more about GraphQL, graphql.org. There's another presentation later that might be interesting. If you have questions, this is my email. But I also have a stand downstairs, so I can make you a demo if you need. So that's it.